Hello, my name is Madeline Olson. I am a senior software development engineer here at AWS, and I'm going to be talking about beyond caching, advanced design patterns in Redis. So let's give an overview of what I'm going to be talking about today. To start us off, I'm going to motivate the use cases that in-memory databases were built to solve, and how that fits into modern applications. Then I'm going to dive into the three main use cases to sort of give a hands-on introduction to how you can use Redis to solve these problems. The three use cases we're going to be talking about are live leaderboards with sorted sets, enhancing your data with geospatial information, building real-time ingestion and analytics systems with Redis streams, and lastly, we're going to wrap it all together with code examples and a real demo showing how you can implement these specific use cases. So, what sort of problems motivated the need for in-memory databases? The problems that modern applications face today means they require extreme performance, large scale, and constant availability. In-memory databases are able to solve these problems by being able to provide very high numbers of requests per second with extremely low latency access. When you're using your phone, you don't want to be waiting for the responses to be going through a typical on-disk database. You want immediate return of the data. With scale, you want to be able to scale up to terabytes or even petabytes of user data and being able to concurrently serve millions of users at the same time. And all of this without sacrificing any availability on your application. So what type of databases solve these applications? Within AWS, we've provided Amazon Elasticache, the managed Redis and memory compatible in-memory data stores. So we solve these three types of problems by making it easy to scale in and out, by adding read replicas or sharding to provide multiple primaries for your data. We also spend time to finely tune our engines to give you the best performance in terms of raw throughput numbers and in terms of price performance. And of course, we are a fully managed AWS service, making it as easy as possible to configure, set up, and manage your workloads, so you're able to focus on solving your business needs. So as I mentioned, we support both Memcached and Redis data stores. So why am I just talking about Redis? Well, that's because Redis is the #1 in-memory data store and often cited as the world's most beloved database. According to Stack Overflow's yearly developer surveys, it's often ranked the single most loved database because it's fast, versatile, is feature-rich, and is very easy to use. In the key value space, it consistently ranks among the most used and most talked about databases, according to DB Engines. So with that, let's dive a little bit into what is Redis. So Redis stands for Remote Dictionary Store. So what that means is Redis is basically a server on top of a bunch of APIs to gather data out of a dictionary. It allows for low latency and high throughput access to a very rich set of key value pairs. In Redis, most people just think about the strings, which are simple key value stores. But in reality, it provides a very rich set of values that users can use to build very complex applications. On top of that, it supports complex features like replication, high availability, snapshotting, and atomicity through Lua scripts and transactions in order to make it easy for users to solve their problems. So when I mentioned that Redis is really just an API for accessing data structures, that's really why people love it so much. When we talk about caching, which is the most common use case for in-memory applications, most people are just using the string data structure, which is you're just storing a block of data inside Redis and having a single key be able to access it. But Redis can do, in fact, so much more. As a hash data structure, so you can store collections of data where you can individually look up and modify items. This is especially common in session storage or other ways like keeping track of an individual user's shopping cart. It also has a list data structure, allowing you to build powerful applications around things like queues and stacks based around the Redis list structure. There's a set, which is an unordered collection of items that allows you to do basic operations like intersecting and doing unions of multiple sets to figure out what's the difference or the total number of unique items. The sorted set, which is a modification of the set, and that introduces a score so that you can also have some sort of ranking within the unordered set. Geospatial information, which allows you to do efficient lookups across distances. Hyperlog log, which is a probabilistic data structure that allows you to estimate the size of sets. And then streams and pub/sub, which allow you to have a collection of ordered items. With all these data structures, Redis is able to solve a vast variety of use cases. As I said, caching is a very popular one, but these data structures allow you to solve all these different use cases. Things like analytics, gaming leaderboards, geospatial, media streaming, session storage, chat apps, message queues, and machine learning. So, without further ado, let's dive into these into more detail to give you a concrete example of how you could go about implementing these use cases. The first use case we're going to talk about is leaderboards. So when many people think about leaderboards, they're thinking in a video game context, where we have a collection of users, and you want to figure out which user has the highest score or the lowest score, or how this user ranks amongst a bunch of other users. But you can also think about it more broadly. Having a ranking of the most popular books, like on Amazon.com, is a good way of thinking about which one is the top bestseller, or the 20th bestseller, the bestseller in certain categories. Those are all leaderboards in a certain sense. So Redis provides a good way to store and manage that information. So how does Redis do that? As I already talked about, Redis has a data structure called the sorted set. The sorted set is a collection of unique items ordered by a score, which produce a rank. So what that means is, in our example here, we have 3 users, Ali, Bob, and Carol, with the scores 1, 5, and 50, and 100 respectively. So the numbers associated with those users are the score, and the rank is where they fall into that ordering. So in this case, Ali would be ranked 0, Bob would be ranked 1, and Carol would rank 2. You can see it's ranked from lowest to highest. Underneath the hood, this is actually backed by what's called a skip list. A skip list is an efficient way to kind of keep track of this information and allows you to give O of log of n lookups, arbitrary lookups, but still constant time insertion and other sorted-based operation or set-based operations. So let's dive into how would you use a sorted set within Redis. I sort of alluded to earlier that Redis is built on top of the idea that it's an API for accessing data structures. So Redis doesn't use anything like a structured query language. Instead, you execute raw commands. So in this case, a sorted set, all of the commands start with the Z operator and are usually pretty straightforward. zadd, for example, adds a member to a sorted set. So you would add like Ali with value 5 into the sorted set. And then to pull that information out, you use something called zrange or zreverse range. Zrange will grab something by its rank. So if you want to get the highest score item, you would get the first returned elements from the reverse range operation. So let's dive into this a little bit more with a concrete example. So here we have, back in the gaming sense, we have 5 users who are each reporting their own scores. We have Dan, Mike, Emma, Lena, and Luke. So you can see that we inserted all 5 of those users into our sorted set, and Redis gave us our response back. In this case, our key, since Redis is a key value pair, is called game1, and then we inserted alternating scores and users. Then, when we wanted to pull the data out, we were able to use the zrev range or zreverse range and say we want to grab from the game1 key the 0 through 2nd rank. And with scores just means we also want to return the scores. So if this was a game and we put all this data in and we wanted to say, like, who are the top 3 scorers, this would be the command we'd run. And we could see that Lena got first place, Luke got second, and Emma got third, and we could give them their respective trophies. So now with that use case under our belt, let's look into another one, which is also very useful, which is geospatial. So many applications involve having end user location-based data. And there's a lot of useful things you can do with that. Maybe you want to recommend them, a nearby ride-hailing service or a nearby point of interest or a nearby recommendation. You want to have an efficient way of being able to say, hey, what is nearby to this user? And that's where Redis comes back into play, because it has very powerful and fast geospatial processing. So if you're able to quickly go and do a bunch of queries to figure out what's nearby, you can give them a bunch of recommendations without, slowing down the end user. So what data type does Redis provide for this? Well, it's a powerful data structure called the Geospatial Index. So the Geospatial Index is really good at saying, here's a collection of items. How far are the items within this collection? And also, which items within this collection are within a radius of a given point? So this is all based on what I said earlier, which is a geospatial index, which is actually internally also built on the same Redis data structure we talked about earlier, the skip list. So as I said, there's basically two types of queries you can say, which is what is within a radius of a given point and what's the distance between 2 points. Since the number of different queries you can ask is relatively small, the number of commands you can use to interact with these are also really small. So geoadd is the same sort of basic primitive we talked about earlier, which allows you to add a member to a geospatial index. Then the two key types of operators we talked about, geodist gets the distance between two elements, and georadius gets the number of members within a given radius. So with that, let's look into an example using actual code. So here we have a geospatial index that we're going to call cities. So it's in the key called cities. So we're going to be inserting two cities, Chicago and Seattle. And then we'll be able to say stuff like, as I said earlier, this was actually backed by a sword set, so you can actually go and access it like it was a sword set. But the intention is you're going to be using it as a geospatial index. So you can ask the question, what is the distance between these two cities? And Redis comes built in with a bunch of different operators. In this case, you can say, what's the distance in miles? And you'll see it's about 1,700 miles. And then the last question we said we can ask is, which cities are within a given point? So in this case, we're giving the longitude and latitude. And we're saying within 1,000 miles, which cities are within this range. So that specific point is actually very close to Seattle. It's only 680 miles away. I think it's actually just south. So that's, and also with dist allows you to also provide the distance. But you can also give you can say with the coordinates, so it actually gives you the coordinates of the response back. This is a very powerful command that really allows you to specify when you want to get out. It makes it very flexible for solving whatever problem you want. So let's dive into our last design pattern, which is streaming. So streaming is really useful when you have a lot of data that you need to ingest and then process. So the first stage of that is as you have data sources and they're generating data. Data sources could be IoT information, they could be sensors, they could be all sorts of stuff, end users doing stuff. And so you need a way to ingest that. So there's traditional streaming-based services like Amazon Kinesis or Amazon managed streaming with Apache Kafka. But you can also actually do this with Redis itself. Redis supports this functionality natively. So once you've ingested the data, then you need to do some sort of transformation on the data. Maybe doing something like a compute operation, or you'll probably have like EC2 instances running operations, maybe doing some machine learning on the information. And then once you've transformed the data, you need to store it back somewhere to be referenced. Again, Redis is another great place to do that end storage as well. So it's used on both sides of the streaming workflow. And then once you're done processing it, you need to do visualization, or if it maybe like you're providing recommendations after reading a bunch of data, then you're basically doing the end product of this, which maybe you're using one of the other great services AWS provides to help visualize the data. All right, so what sort of data structure does Redis provide to help solve this use case? Well, it's very conveniently called a stream. So a stream is a ordered collection of data. It's a very complex data structure underneath the hood. It's actually a radix tree, which is a tree built on top of prefixes of basically blocks of memory called list packs. So all of this specifically for the purpose of it's very efficient to add items to the end and read items from the end. That's kind of what this whole data structure is built around. You can do semi-efficient queries. They're still O of log n if you want to kind of like get like items between 2 points, but it's not optimized for that. It's a little bit slower. And it also supports another powerful use case, which is, maybe you want to watch a video, like stream a video. So you want to say like, oh, I want to start at this point and then just keep streaming from there. But you also might want to say, hey, if you're like consuming in data to be processed, you want to say, I only want one person to process this data. So it also provides a abstraction called a consumer group, which allows you to cooperatively consume a stream. So as always, we can talk about some of the APIs we use. All streams data structures start with the X command. So we have xadd as the basic primitive for adding an item to the end of a stream. You'll see in a second, it's a pretty complex command. Then we also have the xread, which is the kind of the primitive reading data out of a stream. So you'll typically be reading from the end of the stream or from a given point. And also, of course, you can always do arbitrary reads in the middle if that happens to be what you need, if you're like, need to go back in time to look at a piece of data. So let's look at how these commands actually work. So in most cases, you're going to have a producer and consumer set up with this type of application. Since that's kind of like the two parts, we have the production part, the processing part, which is going to be a consumer. So typically, you'll be doing something like an xread on a consumer, where you're saying, hey, I want to be reading in the data. You can see here we're doing an xread on the streams called server B. And the $sign is a special character in Redis that just means give me the latest data. And lastly, there's that block command, which basically indicates to Redis, hey, don't give me any data until there's data. Like don't tell me there's nothing there. Just wait until there's data there. So when we do the xadd, we see we have a similar sort of structure. We're adding to server A, which is not server B, so the consumer doesn't care about this piece of information. And in this case, we're having a series of data, which is the looks like some, maybe some IoT data from a bunch of motors. So nothing happens, but as soon as we go and read the next piece of data, the consumer will go and pop back that stream element we added. And then, of course, as we said before, we can also do arbitrary range queries. So with that, I'm going to jump in and let's go and actually build an application that sort of pulls this all together. So the application I'm going to be demoing is a simple, basically Redis-backed web service. So we're going to be using Django and have a web front end. So with that, let's go ahead and jump in to see kind of what it looks like. So here we see we have an interactive map. And for those that aren't aware, this is Las Vegas, the spiritual home of reInvent. And so the main functionality of this for us can be like a recommendation engine. So when you move around in the map, it will go and show you a bunch of nearby points of interest. So this is all being backed by Redis. So Redis is providing an API to go and fetch this data. And you can see, you can click on the elements and it'll tell you what's going on. So that's one functionality of this website. The other is going to be, it's going to be able to give you recommendations. So like given a specific category, what's it going to recommend? So, and I know this isn't like a Las Vegas thing, but I personally really like Giordano's, a deep dish pizza place, which is actually native to Chicago, back in my hometown. And then another recommendation I would have is Gordon Ramsay's Burger, which was a really good place that I was there last time I was actually at reInvent. So you can see that we have some sort of ranking system going on here, which is probably backed by sorted sets. And it basically gives you kind of like real-time, really fast responses, right? I mean, we could, of course, build this with some other data structure or with some other database as well, but it wouldn't be quite as fast. So with that, let's try to jump into the code and see how this is actually implemented. So there are two parts to this demo. We have our loading aspect, which is dumping data into Redis, and an API portion, which is pulling data out and visualizing it on the screen. So a good best practice to have while building Redis applications, since it's a key value store, is to really think about how you want to organize your data. So in this case, we have a reviews, which is kind of like our common prefix. Then our businesses is going to be kind of our business subsection, and then business IDs. So this is going to just be like a dump of data, which is going to be sort of like how are we going to look up individual businesses. It's going to be stored in a hash, which is sort of a primitive data type we alluded to earlier. It's not really an advanced one, but it's kind of like the backbone of most of your applications. You're really going to be storing a lot of data in a hash, or maybe something like a string. I'll talk a little bit why it's a hash and not a string in a little bit. So the next key sort of schema we have is going to be the reviews. So this is going to be a geospatial index mapping the location data to a business ID. So business ID, again, is what we're indexing the main hash structure on. So we'll be able to look it up quickly. So this will be able to give us like location data. And then the very last one is going to be that categorization we talked about, which is going to be the sorted set. So there's going to be reviews, city data, and then a city in a category. So it'll be kind of a space where we'll be sticking these sorted sets. There'll be the member name will be the business ID, and the score will be the number of reviews. It's kind of going to be like the most popular, not like the highest reviewed. So we have some code kind of just pulling the information out, and then we'll kind of jump into the meat of everything. So as I said, Redis is often called like the world's most beloved database, and this is really why. It's like this is how straightforward it is to stick data into Redis. There's just one command. Just do. In this case, the command's called hmset, which is a hash set command. So we're setting this basically dictionary of data into a key. You can see it's very straightforward, very easy. And so, but now let's focus more on the geospatial part. So we have our geoadd command. So this is what's going to be adding data into our geospatial index. So the geospatial index, we have the business ID, the longitude and latitude, which is the information we sort of just pulled out from our backend data, and then we have the key. One other thing I want to point out here is just like we're never defining that this key is a geospatial index. We're just sticking data there. And that's one of those emphasis that Redis really makes, which is that Redis should prefer to be easy to use and simple. And so an empty key is considered a empty collection of data. So you don't need to define the schema, you just start acting on it, and Redis will figure out what to do. So next, we'll jump into the sorted set code. So here you can see that we're inserting using the zadd command to stick data into our various sorted sets based on the category and based on the city. So in the demo, we were only looking in around Las Vegas. But we can see this can be more generic, right? It doesn't necessarily have to be by we don't have one category, we can have multiple categories. I'd also call it that we're using a batching operation here. So instead of calling each command individually, we're just queuing them all up and just dumping all the data in. This is because we don't actually care about each individual response. We're just trying to get all the data in, because this is being done in a batch load. So with that, let's look into the API. I really want to emphasize just how small and short this code is. We have 37 lines that fully define our API that's responding from our web service. So that client that was calling, it's making JavaScript code to these APIs, and this is all the code we have. So, we have two types of APIs. We're going to be getting the top reviews and basically nearby locations. So those both kind of return the same thing, which is a collection of locations. So this first function is kind of a helper function in order to organize that data and make it, we're organizing into a JSON response, we're dumping it out, and then making it available. And we're using the hgetall command in order to facilitate that. So the next thing is the get top reviews. So we said before we're using the sorted set command. So we'll be using the z reverse range because, as we said, it's in the reverse order because we're going largest to smallest. So we will be doing The rev range will be starting at 0, and we're getting 10 items. We could, of course, be getting more items, and we could be paginating it so you could, be like, oh, I got the first 10 items, but I didn't like any of those. Where are the next 10? All you need to do is add another parameter, shift that over. It's pretty straightforward. And the next API we then implemented was the get nearby locations. So the nearby locations is supported with the georadius, what we talked about. So you can see here there's a lot of arguments. So we have the key, the longitude and latitude, which is the core building block around the georadius. And then we're saying let's get everything within 2 miles and then limit it to 50. So obviously the limit there is not, we just don't want to fill the screen. It's probably worth noting that it's pretty easy that you could combine these two and add more information together, and it wouldn't greatly increase the total execution time of the APIs since Redis is so fast. But a more glaring deficiency of the code I've shown so far is that it's very static. You can't add more data in as you're going along. So to solve that, we can use streaming, right? So we can be streaming in a new set of reviews. So to do this, we're going to use the Redis streams data structure we talked about. We'll extend our key space a little bit. That's kind of why we spent time organizing this earlier, so it's easy to add a new key in without conflicting with old keys. So we have some more data. We have some reviews we're going to be reading in and dumping out, but more boilerplate code. But now the real interesting bit is the xadd, right? So here's we're adding data into the stream. One thing I want to call out here is that we're not actually saying what the idea is. We're just saying, here's the stream, here's the data, here you go. And that's all we really have to do. Redis will take care of everything else for us. The client is actually doing a little bit of help for us to sort of construct the arguments correctly, but it's really just this simple to build a stream and send the data in. So on the other side, we have to have a consumer. So someone has to be consuming this data and actually doing something with it. So here we have our other primitive, the xread. So we're re-reviewing in the same streaming data based on an ID. So this is one of the examples I talked about where it says we just want to make sure we consume the whole stream. So every time we call the xread, we want to give it an ID. Be like, this is the last thing we read about. And then when we actually read the data back in, it's going to tell us where we read up to. And so we can keep calling this read command to get more data out. So then what are we doing with this data? So we're going to be basically taking it in, saying, okay, so we have our leaderboards and our main store. So we're going to increment both of those. And that's why we actually store this as a hash and not a flat string. So we can just do an h-increby, which is a built-in data structure for incrementing a hash value by a specific value. So I'm going to go ahead and kick that off and start streaming in these new reviews. So let's look at a category we haven't looked at before, which is yoga. And you can see Elasticashew Yoga is now slowly kind of kicking up, all in real time. So you can see that Tyler's Awesome Yoga is currently positioned in rank 1 or 2 if not indexing at 0. And you can see slowly as more reviews come in for Elasticashew Yoga, it eventually overtakes them. And you can still see it all works as expected. When we click on it, it still goes to the location we talked about. So that's sort of just shows how simple it is to build a, very feature-rich application backed by Redis. In this case, where you're using Redis as a primary data store, and you of course want to consider what type of data you're storing and what makes sense, since there are some drawbacks to using in-memory databases, which should be considered when building an application. So with that, let me jump into a little more detail about Amazon Elasticache for Redis, and kind of give you a send-off if you want to go and try to build these own databases. So as I said earlier, Amazon Elasticache for Redis provides extreme performance. We do a lot of tuning to make sure all your commands are sub-millisecond and you get the best price performance you can. We also emphasize security. We make sure security is our #1 priority. We make sure that your application is able to meet the security requirements of your institutions. We are fully managed. We simplify hardware provisioning, software patching, configuration, monitoring. We are open source compatible with all the major Redis APIs and clients. We also recently launched a lot of improvements to availability. We have a new multi-AZ functionality. We support cross-regional replications with up to 2 passive replicas in other regions, so you can have geolocal reads within your region. We also support automatic failover, and clustered configurations help shard out. And of course, we make it very easy to scale out your application so that you're not taking downtime if you ever run into scaling limitations. So these are some resources if you want to get started. Go ahead and check our FAQ. We have blog posts. You can find all the relevant recent blogs to find best practices. If you haven't already, go ahead and check out the What's New in Amazon Elasticache, DAT 209, to sort of get even more information about the recent launches that we've seen in Amazon Elasticache. And if you want, you can follow me on Twitter. I tweet about Redis sometimes. I also am a very active contributor in the open source Redis community. With that, thank you for coming to my talk.